All right, kiddos, we are going to start with triangles today. This is lesson 3 of chapter 14, and you can do this anytime before Friday, so you don't have to do 2 in one day just because there's 2 videos that popped up today, okay? So go ahead and get your notebook out, and we are going to start talking about right triangles. So a right triangle is a triangle with one right angle. So go ahead and write that down. Pause it if you need to. And if you look at a triangle, and you see that it has one right angle, it will have right now for you, it'll always have that square in there, so you know that that is 90 degrees. Later on, you're going to learn how to use a protractor, like it was in that video that we watched yesterday, and it'll show you how to measure an angle. But right now, it's going to always show you if that little square is in there. It means you can fit a perfect square in that angle, and it's a right angle. Now, a right triangle only can have one, because if we have something like this, and we have this right angle and this right angle and 3 sides, there's no way that it can be a triangle because it's open right here, right? And a polygon has to be closed. And even if I closed it like this, now it turned into a quadrilateral. So you can't have a triangle with more than one right angle. It's only ever going to have one. But it could also look like this. Oh, that shouldn't be crossed right there. I better erase that because let's try that again. You could have one that looks like this, and this could be the right angle, right? It could be any of the angles of the triangle. It doesn't have to be in the bottom corner. It could be anywhere, but it's just going to always show you that little square right there shows you that it's a right triangle. Okay, let's go ahead and look at our math book, but keep your notebook open for a second because we're going to do one problem. We need to find the area of this composite figure. Now remember, a composite figure means that you have 2 different shapes put together. So you have this shape and this shape put together. So see if you can find the area of this, I was supposed to underline that, composite figure. Pause the video and see if you can do it. All right, now let's think of this bottom one first. We're going to draw 3 lines so that we have 4 inches going across the bottom. We have this in 1, 2, 3, 4, right? And we're going to draw 4 lines so we have 5 inches coming down the side. That needs to finish up. Okay, 1, 2, 3, 4, 5. So let's count by 5s and see how many squares we have, because area, we're always finding it in squares. We have 5, 10, 15, 20. So this one is going to be 20 square inches. We can also figure that out by, remember, multiplying one side by the other side. So 5 times 4 equals 20. Well, on the top, instead of writing 11 lines and counting all those up, let's just multiply the 2 sides. Since you know how to multiply, 12 times 3. We could do our count by 12 song 3 times. Let's see, 12, 24, 36, right? So it's going to be 36. But it can't be just 36 or 20. What do we have to do to find the total? Yep, you got to add them up. So 36 plus 20, 6 plus 0 is 6, 3 plus 2 is 5. So it's going to be 56 inches, dot that, squared or square inches. Let's see if we got that right. Good, 56 square inches, way to go. Okay. Go ahead and open up your book. Now here is the area. This is the time when you are going to need to measure these triangles. So if you have a ruler or you have a tape measure, go ahead and try and measure each of those sides and see if you get the right thing. Measure in inches because it's saying inches right there. So go ahead and measure them really quick and then we'll go over it. Okay, so I'm going to fill in the measurements for us. So each of these triangle sides are 1 inch. Each of these triangle sides are 1 1/4 inch. Now, triangles aren't always going to have the same sides, right? If they have all of the same sides, that's great, but it's not always going to happen. And you can tell that by triangle C. So the 2 top sides are 1 inch and the bottom is 1.5 inches. And this one, we have 1 inch, 2 inches, and then 2 1/4 inch. Ooh, that's good because I didn't really look at that. Up top it said measure to the nearest 1/4 inch. Underline that. Right? So if you rounded it to 2, let's go to the full 2 1/4 so you can see how big it is. Okay? Good job. All right, on the next page, oh, I had looked at this one before. So this one says compare the angles of each triangle below. Which triangles are the right triangle? This is going to be triangle A because you can see it has a right angle in here. Now this one looks like it could almost be 90 degrees, but it's less than 90 degrees. We know because it does not have the square in it, because it'll give us that right now while we're working on right angles. It'll say, this is a right angle, a perfect square fits in there. And this one does not have a perfect square that fits in there. So let's see if we got those right. Yes. Okay, we know that this is a right angle because we can see that it's a right angle, and we know a perfect square is going to fit inside of that. Okay, talk about it. Let's go on to this next one. Okay, identify each triangle with what you discovered about the side lengths. So, which one of those triangles from the top had no side lengths that were the same? Which one had all three side lengths the same? And which one exactly two side lengths that are the same? So if you go up previously to looking at what we had looked at after measuring them, you can see that D didn't have any side lengths that were the same, right? From that first page where we had measure it. All three side lengths were the same on A and B, and only two of them were the same on triangle C. And you're going to find out triangles that have side lengths have names. We're not going to learn those right now, but we have equilateral, isosceles, and the length of the sides can actually also define a triangle, but we're just kind of getting started with that. So you just have to identify if they are the same, two of them are the same, if all of them are the same, or if none of them are the same. Okay? All right. Let's draw a conclusion if we look at 4 through 5. Which triangle has a greater angle than a right angle? So go back and look at 4 and 5. Which one has a triangle that's greater than a right angle? So look at those first ones. Which triangle has all three angles that are less than a right angle? Which of them all look smaller? And explain how a triangle is a special kind of polygon. So try answering those questions. Go ahead and pause the video. Okay, if you look back up at triangle B, that one has an angle that is greater than a right angle, so it's bigger. Remember we said that was obtuse. Triangle C has all three angles that are less than a right angle. And a triangle is a special kind of polygon because it has three straight lines that don't cross each other, and it's a closed figure. It's actually, I don't know if it's special kind, it's just a polygon, but it's explaining there how it is a polygon. Good. Okay. You are going to be working on your practice it pages and your apply it pages. Now, here again, it's going to be asking you to measure. So it'll be really helpful if you can find a measuring tool, measure these, and answer the questions on the next two pages. Go ahead and pause the video and go ahead and get that done. Okay. So this one, all three sides are 3/4 of an inch. This one is 1.5 inch on this side. This is longer, and these two sides are an inch. We have 3/4 of an inch on this side, 1 inch on this, and 1.5 inches right here. This is 1, 1.5, and 1 3/4. Okay, state the number of sides with equal lengths. How many sides have equal lengths here? All three of them, right? Let me get my pen out. How many sides have equal lengths here? Just this one and this one, so just two sides, right? How many sides have equal lengths on this one? None of them. And how many have equal lengths on this one? 0. Okay, now it says circle the triangle on this page that is a right triangle. Well, this one we know has it right there, so we'd circle this one, and this one has a right angle right here, so we would circle that one as well. Okay. Go ahead and make sure you've finished all of these, and then we'll go over it. It says compare the angles of each triangle and then circle the correct description. Okay, does this have one right angle? Nope. Is one angle, sorry, let me get my tool. One angle is greater than a right angle. Yeah, this is an obtuse angle. You can tell it's bigger than a right angle, so we would circle this one. Is this a right triangle? Yes. Are three angles less than a right angle? No, because this is equal to a right angle. These two angles are less than a right angle, but this is the one you're going to want to circle. Okay, 3 angles are less than a right angle, or 1 angle is greater than a right angle. None of these look bigger than a right angle to me. They all look like they're less than a right angle. This one has what right angle? You know what? That looks like it could be a right angle, but there's no square right there. So we know that that's not a right angle. 1 angle is greater than a right angle. This one has got to be bigger than a right angle then, because we know it's not a right angle, and it is definitely not smaller than a right angle. Okay, and then circle the one that are right triangles, just this one. Okay, just that one is a right triangle. Good. All right, one side of this Egyptian pyramid is the shape of a triangle, right? Because we're just looking at one, the pyramid is actually a 3-dimensional figure, but we're just looking at one side of it. Circle the phrases that best describe the angles of the right triangle. All angles are greater than a right angle. Well, sorry, it didn't say it was a right triangle. It was just the shape of a triangle. So are all of them bigger than a right angle? You actually can't have a triangle where all of them are bigger than a right angle, because then it would be like bigger, and then this would have to be bigger, and then that would have to be bigger. That we already have 4 sides, right? So you can't have a triangle where all of them are bigger than a right angle. So can't be that. All angles are less than a right angle, or 1 angle is a right angle. These all actually, you can eyeball that and say they all look smaller, but also if it was a right angle, it would have our little square in there, right? Oh, that's not right. It would have our little square in there, and none of them have that. So all of them are going to be less than a right angle. Okay. Number 17, measure the sides of the triangle to the nearest 1/4 of an inch. Then state the number of the sides with equal length. So let's just look at that. Ooh, these top 2 are 1 1/4. Did you measure that correctly? The bottom is an inch, so we only have 2 that are equal lengths. Draw a triangle that is a right triangle. Then draw a triangle that is not a right triangle. So if I was going to write this, I would say, okay, here's my perfect right triangle. And because I'm saying it's a right triangle, I better say this is a right angle. Now, if I wanted to, let's take that one off. If I wanted to draw one that wasn't, I could say, oh, I want to make a little bitty. You can tell this is less, because if it was straight up and down, then it would be a right angle. But these are all less than right angles. Let's see how they did that. Oh, yep, they drew one with a right angle on this side, and then 3 little angles on that one. Okay, how are all triangles the same, and how can they be different? Okay, all triangles have 3 sides. All triangles have 3 angles. They can be different because they can have, their sides can be different lengths or the same length. They can have acute angles or obtuse angles or right angles. Their angles can be different. So there are lots of ways that they can be the same. Well, there's 2 ways. They're polygons with 3 sides with 3 angles, so they're always the same. But they can differ in the measure the length of sides and the measure the angles, like we talked about. There's lots of different ways they can be different. And there's lots of different triangles. Okay, if you want to do your homework pages, you can. If you are not really up for it, you don't have to. But make sure you turn in those 2 pages, pages 847 and 848, by the end of the week. Okay, see you guys tomorrow.